Breaking news. At precisely 02:19 a.m. UTC, less than 8 hours ago, a quiet data stream arriving from 3 continents triggered an alert that no astronomer on duty was prepared to see. What began as a routine calibration pass became something else entirely. Today, the impossible just happened. An interstellar object we believed we understood, an object already cataloged, modeled, and effectively dismissed, produced a continuous, uninterrupted dataset lasting exactly 28 hours. That alone should not be remarkable, but the contents of that dataset defy everything we know about natural cosmic bodies. Moments ago, analysts confirmed the anomaly across independent systems. This changes everything we thought we knew. If you want more verified cosmic updates like this, calm, factual, and real-time, make sure you hit like and subscribe, because what you're about to hear is not speculation, it's data. The confirmation did not come from a single telescope or a single agency. It came from a network. NASA's Deep Space Network first flagged the irregularity during a downlink from the Goldstone complex in California. Within minutes, the signal was independently mirrored by ESA's new Norcia station in Western Australia and the European Space Network's antenna in Cerbero, Spain. Simultaneously, spectral data from the Atacama Large Millimeter Array in Chile showed a deviation that could not be dismissed as noise. Harvard's Center for Astrophysics, Caltech's Jet Propulsion Laboratory, and teams working with both the Hubble Space Telescope and the James Webb Space Telescope were looped in before sunrise. This was not a localized glitch. It was global. And for the first time since 3I Atlas entered our solar system, every major observatory was looking at the same thing and seeing something that did not belong. To understand why the next 28 hours matter, we need to rewind. 48 hours before the event, 3I Atlas was behaving exactly as predicted. Its heliocentric velocity measured 58.7 kilometers per second, consistent with previous interstellar objects. Its trajectory showed no unexpected perturbations. Thermal readings placed its surface temperature near 430 Kelvin as it approached perihelion, well within expected parameters. Spectroscopy revealed a familiar mix of silicates, carbon compounds, and trace volatiles, nothing extraordinary. 11 hours later, however, a subtle discrepancy appeared. A fractional acceleration, just 0.0003 meters per second squared, registered across multiple instruments. Small enough to ignore, except it didn't decay. It persisted. 6 hours before the main event, the object's light curve flattened, not smoothed, flattened. Natural bodies tumble, they vary, they flicker. This did not. Its rotational signature became unnervingly uniform, as if the object had stabilized itself. No known passive process could do that without expelling mass or energy, and yet there was no outgassing, no debris, no coma, just silence. At T-0, the moment now stamped across internal reports, the first pulse appeared. It was not bright, it was not loud, it was precise. A narrow-band emission centered at 8.42 GHz emerged from the object's trailing edge, lasting exactly 2.7 seconds. Then it stopped. 4 minutes later, it happened again. Same duration, same frequency. Over the next 28 hours, this pulse repeated 417 times. No drift, no degradation. The signal-to-noise ratio remained constant to within 1%. Natural astrophysical processes do not behave this way. No rotating magnetar, no plasma instability, no cometary jet. This was controlled. As the hours unfolded, more anomalies layered on top of the first. Infrared imaging from JWST revealed a subtle shape change, not a fragmentation, but a redistribution. The object's mass profile shifted inward, increasing its central density by an estimated 9% without any corresponding loss of material. Gravitational modeling from Caltech showed the object's effective moment of inertia decreasing as if it were compacting itself. At the same time, optical data from Hubble showed a faint color shift from neutral gray to a slightly bluish hue, corresponding to altered surface reflectivity. This was no longer a passive visitor. It was doing something. Teams scrambled. I remember staring at the data feed as the realization set in. This was not a single anomaly. It was a sequence. And sequences imply intent, or at least process. Dr. Elena Varga at ESA led the first round of simulations. Using high-resolution gravitational models, her team tested every known natural explanation: asymmetric outgassing, tidal stress, thermal cracking. None fit. The acceleration profile was too smooth. The energy budget didn't close. Meanwhile, Dr. Marcus Hugh at Harvard ran spectral analyses comparing the emissions to known astrophysical sources. The result was unsettling. The emission lines were clean, almost engineered. No natural process could produce such symmetry, his preliminary report stated. Not everyone agreed. At NASA, Dr. Paul Renner argued for an exotic but still natural explanation: a previously unobserved phase transition in interstellar ice under solar heating, producing directed momentum without visible mass loss. It was creative, it was cautious, and it failed under scrutiny. The required temperatures exceeded measured values by hundreds of Kelvin. The model collapsed. As the debate intensified, the dataset kept growing. 12 hours into the sequence, the pulses changed, not in frequency, but in pattern. The intervals between emissions began to follow a numerical structure: 2, 3, 5, 7, 11. Prime numbers. This was no longer random. It was responding. The pulses were not aimed at Earth, but their detectability suggested no attempt at concealment either. It was as if 3i Atlas was simply operating. Then came the second wave. At hour 19, one segment of the object, previously unresolved, vanished from radar and optical sensors simultaneously. No explosion, no debris. It did not move away. It simply ceased to interact with our instruments. Gravitational effects remained unchanged, implying the mass was still there or had been redistributed beyond detection. Quantum noise levels spiked briefly across multiple detectors, then returned to baseline. This contradicted every assumption made in the first phase. Control rooms went quiet. Internal communications tightened. Encrypted lines replaced open lines. At least 2 agencies issued internal advisories instructing staff not to speculate publicly. World governments were briefed, not because there was a threat, but because there was uncertainty. Satellites in high Earth orbit reported minor magnetic fluctuations measured in nanotesla, coinciding with the pulse peaks. Radio operators logged brief blackouts at specific frequencies. Even migratory bird tracking data showed small deviations. Subtle, correlated, uncomfortable. And then, just as abruptly as it began, the dataset ended. At exactly 0619 UTC, the pulses stopped. The acceleration ceased. 3i Atlas returned to a ballistic trajectory indistinguishable from inert matter. The object continued on its path, silent once more. In the aftermath, the question wasn't what happened, it was why now? Maybe we're witnessing the end, but an invitation. Or maybe this was a system test, something waking up briefly before going dormant again. The universe has always been vast and indifferent, but indifference does not leave patterns. As I look back at those 28 hours, I'm struck not by fear, but by precision. Whatever 3i Atlas is, object, artifact, or something entirely new, it behaved in a way that suggests rules, and rules imply design. The final report ends with the single unresolved note. During the last pulse, the object's orientation shifted by 0.02 degrees toward the inner solar system. What happens when it wakes up again? Subscribe to follow the next update. This story isn't over.